See the next position. Now your object AB is kept at 2f1. So you can see a ray of light parallel to principal axis. After refraction it will pass through f2, and the second one, a ray of light passing through optical center, comes out without any deviation. They both meet here at this point. So if you draw this perpendicular line, that will be your image A bar B bar, and it is at 2f2. So what is the position of the object at 2f1? What is the position of the image at 2f2? Now what is the size? It's of the same size. The size is same. So size of the image is same. And what is the nature? Because it's formed on the other side of the lens, it is real and inverted. You have the next position when the object is kept between f1 and 2f1. Object AB, ray of light parallel to principal axis. After refraction it will pass through f, and another one, this passing through optical center, comes out without any deviation. Or you can draw the other one passing through principal focus. After refraction it will travel parallel to principal axis. Okay, so whichever you draw, it will meet at this point. So this is B bar, A bar. This is the image. So what is the position of the object between 2f1 and f1? What is the position of the image beyond 2f2? What is the size? See this size of the object. This is the image. It is enlarged. And what is the nature? It's on the other side. So it's called a real image, and real images are always inverted. Now this one is very important when the object is kept at f1. When the object is kept at f1, you can see ray of light parallel to principal axis. After refraction it will pass through f2 or principal focus, and the other one passing through the optical center, comes out without any deviation. Now they will meet, but not very close to this lens, but it will meet far away, and that will be at infinity. So the image is formed at infinity, and the size will be larger. It will be highly enlarged image because these rays will meet far away. So as you go away from this, the size of the image will keep on increasing. If you look at this figure, see the size. It was here between f2 and 2f2, so size is small. Then now when the image is at f2, it is little bigger. That's almost the same size. Then as you go beyond 2f2, the size keeps on increasing. So in that case, if you see this one, it is going to meet far away. So as the distance increases, the size increases. So only in this case, when the object is kept at f1, then the size of the image will be highly enlarged, and it is real and inverted. Now this next position, let us draw this one. So let's see this position. The object is kept between optical center and f1. This is the object. So first let's draw a ray of light parallel to principal axis. After refraction it will pass through f2. That's this one, a ray of light parallel to principal axis. After reflection passing through f2. Now let's draw another one that is passing through the optical center. But after drawing this, you see that they are not going to meet because they are diverging. They are neither parallel or they are converging, but they are diverging. So they will never meet this side. So what we have to do, we have to extend this backward. So when I extend them backward, they appear to meet here at this point. So here the image will be formed. Now what is the size of the image? Or let's see the position of the object and the image. The position of the object is between optical center and F1 and O. What is the position of the image? It is formed beyond 2F1. Okay, it's beyond 2F1. Now what is the size of the image? See the size of the object. This is enlarged. Now what is the nature? If the image is formed on the other side of the lens, it is called real because the lenses are transparent. So the image should be formed on the other side, that is real. But here it is formed on the same side of the lens. If it is on the same side, it will be virtual, and we know that virtual images are erect. So it's virtual and erect. So you can refer the diagrams that I have drawn, and you can take all this position one by one for the object, that is at infinity, then beyond 2F1, at F1, all these positions. You have got 1, 2, 3, 4, 5, 6 positions. Okay, and draw the ray diagram for all that one by one. Now for concave lenses, there are only 2 positions. Convex lenses, there are 6 positions, so 6 ray diagrams, and for this only 2. One, when the object is kept at infinity. When the object is kept at infinity, the ray of light parallel to principal axis, after refraction they will diverge, so they will never meet. So you have to draw backward, and whenever you're drawing backward on the same side, it should be with dotted lines because they are not real, they are virtual, so they meet at F1. And the second is between 2F1 and F1, the ray of light parallel to principal axis, after refraction it will diverge, here passing through optical center, so they both appear to meet here. So the image is formed on the same side between optical center and F1. Only 2 positions for the concave lenses. Now your lens can be a freehand figure, or you can keep the compass at 2F2, 2F1 and draw this one, and other side 2F2 and draw this arc and draw this and join the ends. Or this could be freehand. Why? Because we are considering only that perpendicular line, that dotted line, from that surface the rays will refract, not from these curves or the arcs. Okay. So once again I repeat that your homework is you have to draw all the ray diagrams for the 6 positions of the object for not a concave but for convex lens. Okay, you can refer this table for the position of the object. So that's all in this class. Thank you so much and God bless you all.